All right, so this word problem here is going to be a work rate problem, a problem where we have two or more people working together to complete the same job. These problems are probably one of the trickiest types of word problems to do to get an exact answer for, but on a multiple choice test, one of the easiest word problems. So I'm going to try to go through the easy approach to a problem like this. So what should be going on behind the scenes as far as the actual math here is that you're going to be setting up a rational equation based on the work rate formula of 1 over the time of one of them alone plus 1 over the time of the other one alone equals 1 over their time together. Then you'll want to clear the fractions by multiplying both sides by the LCD. This is typically going to result in a quadratic equation. So in this particular case where we end up with a quadratic equation, it's not factorable, so you got to use the quadratic formula, get an answer there. You got to make sure that the answer you're getting actually answers the question. A lot going on here. So let's start this problem off, but once I've identified some of the variables, I want to go with our common sense approach to this and see if the common sense approach might be able to actually get us the answer without doing all that work. So as we read through this problem, together Karen and Tom can clean their whole house in 3 hours. Alone, Karen can clean the house in 1 hour less time than Tom can alone. About how long does it take Karen, working alone, to clean the house? So there's a couple strange tricks in here that are a little sneaky that I want to make you aware of. So first of all, let's define what our variables are in this problem. We're going to have the time that it takes Karen to clean the house alone. We're going to have the time that it takes Tom to clean the house alone, and their time together. So their time together is straight up given as 3. Now, if you're following along, don't write down what I'm about to write down because this is where things get a little bit tricky. So it says Karen can clean the house in 1 hour less time than it takes Tom alone. So what's tempting to do here is to say it's x minus 1 for Karen and x for Tom. That is if we were just literally translating what's there on the paper. Here's the problem with us translating it in this way early on in the problem. We're about to get elbows deep in some nasty math. When we finally get out of this elbows deep math and we finally get an answer for x and we look at that multiple choice option and say, there it is! I'm so happy that my math after 10 steps finally appears as a multiple choice option. Let me mark it. Well, when you solve for x, what are you solving for? Well, according to what we have written down, we're solving for Tom's time alone. What were we actually asked for in this problem? Karen's time alone. So if you actually gave the answer of x for your final answer, even though you did 99% of the work right, you're going to get 0 points in this problem because it's not what you were asked for. You were asked for Karen's time. So based on our current setup, you'd have to remember to then go back and subtract 1 from that answer that you get. What I would rather do is I would rather rewrite how I define my variables. I'd rather define Karen to be x, and that way Tom is x plus 1. Because if it takes Karen 1 hour less, then it means it takes Tom 1 hour more. Those two things mean the same thing. And this way, when we actually solve the problem, we're going to end up with x as the answer, which actually answers the question. That's the big thing you want to look for in setting up a word problem, is make sure x actually answers the question. So before I get into the nitty-gritty math, let's talk about the common sense approach, which in this case, in these multiple choice options, will actually get us the correct answer. The common sense approach that I want it to take is to start off saying, if they work at the same speed, and they don't, but if they worked at the same speed, then Karen's time alone and Tom's time alone would both be 6. This comes from the fact that it would take them twice as long alone as it does together. So if it takes them 3 hours together, then if they're working at the same speed, then each one of them would take twice as long. It would take them 6 hours. Let's put a unit in here. 6 hours alone. So if they worked at the same speed, but they don't. So Karen takes 1 hour less. So what that tells me is that Karen takes less than 6 and Tom takes more than 6. So Karen's time alone should be less than 6, and Tom's time alone should be a little bit more than 6. But in order for that to happen, Tom's time alone also needs to be less than 7. Similarly to that, Karen's time alone needs to be bigger than 5. And the reason I know it has to be bigger than 5 is if she was less than 5, if she was 4.5, then he'd be 5.5, which can't happen because he needs to be bigger than 6. So this common sense here that tells us Karen is somewhere between 5 and 6 hours tells me the answer is B. It's the only right answer that's between 5 and 6. So all we had to do was use some common sense. The only math we really had to do was to say double their time together and use that to then figure out where she's at. Now, if we want to go through all the steps of this problem, it's going to amount to, say, 1 over x plus 1 over x plus 1 equals 1 over 3. We're going to multiply both sides by the LCD, which is 3x plus 1. So in other words, I'm going to put that into the top of every single fraction. And I'm going to write quickly because I'm just doing this for the sake of completion, because quite frankly, we don't need to do all this. That's the whole point of what I showed you earlier, is that we already have the answer. So we can distribute the 3. We've got 3x there. We can distribute this x. We can combine like terms over here. We can subtract the 6x, subtract the 3. Whoa, sorry, I went too far. Now we use the quadratic formula, so opposite of b plus or minus square root b squared minus 4ac all over 2a. So we have 5 plus or minus the square root of 37 over 2. Which again, if we want to go ahead and just use some ballpark math without a calculator, square root of 37 is about 6, because square root of 36 would be 6. So if I wanted to do this without a calculator, I really could. So we're going to get about 5.5 there. This guy over here is negative, so he's stupid. And so an answer about 5.5.